Okay, so here's that present value stuff. This is class 33B if you're Monday, Wednesday, Friday, and it's 23D, the last video, if you're Tuesday, Thursday. So we are going to talk about present value, and this is really where I think it's valuable to get in there and work those problems. I'm not sure how great the video is at this, but I will do my best to try to explain it. Okay, so time value of money. What's present and future value? $1 received today is worth more than $1 to be received in the future because you can invest today's dollar and earn additional interest, so you'll have more cash next year. Right? So if I said to you, hey, would you like to have $100 right now, or would you rather have $100 next year? You'd say, oh, 100 right now, right? Because you can invest it and earn interest. So, the time value of money concept explains why we prefer to receive cash sooner rather than later. Now, these factors should look pretty familiar to you. The time value of money depends on these key factors: the principal amount, the number of periods, which is time, right? How long you're going to have it, the number of periods, and the interest rate. So P, N, and I. The P, principal, refers to the amount of the investment or the borrowing. We state the principal as either a lump sum or an annuity. Okay, so I think this is a new concept. So when we've done notes payable, notes receivable, we've talked about a lump sum, a principal, right? But sometimes you can pay or receive money, payment after payment after payment. We call that an annuity. An annuity is a stream of equal cash payments made at equal time intervals. For example, $100 cash received per month for 12 months is an annuity. The number of periods, N, is the length of time from the beginning of the investment or borrowing until termination. All else being equal, the shorter the investment or borrowing period, the lower the total amount of interest earned or paid. Right? So obviously time affects the dollar amount of interest, right? Principal times the rate times the time. Right? So more periods, more interest; fewer periods, less interest. The interest rate is the percentage earned on the investment or paid on the borrowing, and can be stated annually or in days, months, or quarters. The interest rate must reflect the number of time periods in the year. So this is that, you know how when we've been doing our notes payable, we'll go like 3/12 when it's 3 months, right? Or 6/12 when it's 6 months. So you have to match that rate. You have to match the time to the rate. So we already know that. Simple interest versus compound interest. So there's two ways to calculate interest that we haven't really talked about. In fact, up till now we've just been doing simple interest. I tell you, you owe 3 months interest, and you go 3 divided by 12 times the principal times the rate, and that's simple interest. Simple interest is calculated only on the principal amount. That's what we've been doing up till now. Compound interest is interest calculated on the principal and on all previously earned interest. Compound interest assumes that all interest earned will remain invested and earn additional interest at the same rate. Alright, so this is the new concept, compound interest. So up till now we've just said principal times rate times time, and we calculate an interest amount. Well, compound interest imagines, well, what if you then took your principal and added that interest back, so it kind of became like the new principal. So if you had $1,000 for a year at 10%, so that's $100 of interest, right? So then you take that 1,000 plus that 100 for 1,100, right? So now your new principal is 1,100 times 10%. So your next year's interest is 110, right? So that's compounding, right? So you keep adding to it. So here's a table that sort of gives you an idea about this. Exhibit 12A1 on page 617 compares simple interest at 6% on a 5-year $10,000 investment. So this first column is simple interest, right? 600, 600, 600, 600 for a total interest of 3,000. Or compounding. You leave the interest in there, and the first year you get 600, but then you put it back in, so interest compounds on 10,600, which means the next year's interest is 636, which you add back, right? And then the next year's interest is 674, and so on and so on. So till you ultimately, your total interest compounded is 3,383. So quite a bit more, actually 10%, more than 10% more than the non-compounded interest, than the simple interest is what we call this first column simple interest. Next, compounded. All right. As you can see, the amount of compound interest earned yearly grows as the base on which it is calculated grows. Over the life of the investment, the total amount of compound interest is more than the total amount of simple interest. Most investments yield compound interest, so we assume compound interest rather than simple interest for this chapter. You will not be required to calculate present value. Be familiar with terms and logic. All right, so I'm not going to expect you to calculate that, but be familiar with what we mean by that. Present value of a lump sum. The present value of $1 is found in Appendix B, Table B1, and is used to calculate the value today of one future amount, a lump sum. The data in each table, known as present value factors, are for an investment or loan of $1. Right? So they're just giving you these little decimal point things, and they're assuming that it's for $1. Obviously nobody borrows just $1, so you just multiply that by the amount you really borrow. To find the present value of an amount other than $1, multiply the present value by the future amount. We determine the present value factor from the table labeled present value $1. Appendix B, Table B1. We use this table for lump sum amounts. We look down the 6% column, across the 5-period row, and find the present value factor is 0.747. If approximately 9,997 is invested today at 6% for 5 years, at the end of 5 years, the investment will grow to 13,383. So we need these tables because of that compounding. All right? We can't just take principal times rate times the time when there's compounding. Well, you can, but then you have to do it every single interval and add that interest back in. So, present value of an annuity. Right? So remember we talked about annuities are this flow of payments over time. Now assume that instead of receiving a lump sum at the end of 5 years, you will receive $2,000 at the end of each year. This is a series of payments. $2,000 over equal intervals. So it is an annuity. How much would you have to invest today to receive these payments, assuming an interest rate of 6%? We determine the annuity present value factor from the table labeled present value of ordinary annuity of $1. So again, you've got this table that's going to take all that into account. So you look down the 6% column across the 5 row, and you find the annuity present value factor is 4.212. So the chart shows the initial investment for 1 year, 505. At that period, the first withdrawal takes place, leaving a balance of 69.29. At the end of 5 years, the ending balance is 0, so that proves the present value of 2,000 is 84.24. So what does that mean? Well, we can use what we have just learned about the present value of a lump sum and present value of an annuity to calculate the present value of bonds payable. The present value of a bond, its market price, is the sum of the present value of the principal to be paid at maturity, a single amount, a lump sum, so present value of $1, right? So you got the lump. Then the present value of the future stated interest payments. So those interest payments are an annuity. So an annuity, because it occurs in equal amount over time periods, present value, right? So this concept's important when valuing a bond because you're getting that one lump at the end and you're getting an annuity. And there's an interest rate involved. So you can use that to figure out what it's worth. So let's do this. Assume the following information. Smart Touch Learning issues 100,000 of 5-year 9% bonds that pay interest semi-annually. Market interest rate is 10%. Maturity payment equals 100,000. Periodic interest, 4,500. Interest rate is 10%, right? 5% semi-annually. Number of periods, 10, right? Twice a year for 5 years. So now you can use those tables to figure out what that bond's worth. Pretty cool, huh? So, let's compute the present value. The face value of the bond is 100,000, and therefore the market interest rate for each semi-annual period is 5%. We use 5% to compute the present value, and the present value of these bonds is $96,149. Let's look at that. The present value of the principal is $61,400. So you've used that present value table times 100,000. So the factor you find on the table is 0.614, right? 5%, 10 periods. You look on the table, 5%, 10 periods. Oh, 6.14. 6.14 times 100,000 is 61,400. So if somebody says to you they're going to give you that 100,000 5 years in the future, 10 periods, half each, well, then you'd be willing to pay $61,400 for it. But on top of that, you're going to get interest every 6 months. So that's worth something, right? So you're going to get 100,000 times 9% times 6/12, right? Times 7.72. That's that factor from the table. So that's flow of the interest is worth $34,749. So when you add the $61,400 and the $34,749, what you'd be willing to pay for that bond is $96,149. Right? All right. Let's suppose that the interest rate drops a little bit, right? So that market interest rate is only 8%, whereas those bonds are at 9%. So you're going to recalculate that. So we're doing what we just did, but we're assuming the market interest rate is 8%. Right? So present value of bonds payable at a premium, right? Because the bond itself has a higher rate than the market. Well, you go to your future value table and you're using the market rate, 8% or 4% for 10 period, 8% for 5, 4% for 10, 100,000 times the factor is 676, right? So that lump sum is worth 67,600. That annuity, the interest coming every month, is the factor is 8.111. We looked up on the table, 36.5. So you add 67.6, 36.5, and the total value of that bond is $104,100. And that is why understanding present value is important to doing bonds. So I think you'll want to maybe practice some of that, but I think you can understand this idea that the face value of the bond is going to govern how much that bond is worth, and also the annuity, the stream of the interest, is going to add to what that bond is worth. So you have to understand what people pay for it today, and that's governed by the present value. All right, so we'll work on those problems in class, and be sure and ask questions in class. All right, see you there.